Okay, talking quite quietly at the moment because I don't want to wake anybody up in the house, but another Banggood electronic kit. We have a Christmas tree. It's that time of year, so I thought we would order one of these and put it together. Now this one kind of slots together, I think, like something. There we go, like that. Christmas tree, and then that will eventually get soldered into the base like that. Okay, so that's our Christmas tree. They're quite nicely made. I do like these Geekcreit kits, although they seem to be a little bit more expensive than other kits for some reason. I'm not sure why, but there you go. And you can see here the placement of all the components are printed onto, or silk screened onto the PCB like that. And we have some resistors there and there. I'm conscious the lighting isn't great here. See if I can improve things a little bit. Knocking the camera. Now I'm doing it. Try and stabilise that a bit. I appreciate the camera's facing the other way to me, so apologies for that. And of course the case comes in, as always, this paper covered clear acrylic plastic, which will hopefully look quite nice when it's finished. And then we've got a bunch of LEDs, which I believe are multicoloured LEDs. Where are we? Oh, there we go. Multicoloured LEDs, and to light it all up, and we've got all the respective nuts and bolts to put the case together. So first thing to do is to put together the resistors, and we have some 100 ohm resistors, I believe. I don't know if these are all the same value. I don't think so. I think these are 100 ohm. What have we got? Brown, black, brown. Is that it? I think that's right. But I shall double check that. So we'll do the resistors in a moment. Okay, now I've relocated the camera in a somewhat more sensible position. We'll start piecing this thing together. So the first thing to do is to start off with one of the boards, and we have a board A and a board B. And you can see the letter A there and the letter B. And what we now need to do is to start populating with these 100 ohm resistors. And we're starting off with R7. So if I just bend the resistor down like that, pop them in there. So R7. The next one is R6. And the next one is R4, which goes in there like that. And turn the beastie over, and I just tend to splay the pins out a little bit just to hold them in place, hold the resistor in place like that. What I shall do is just dab a little bit of solder on one pin of each resistor, and then I can just check that they are properly placed and seated like that, and pop this one around there and blob, there we go. Nice shiny solder, and we can see that the resistors are holding on there, oops, quite nicely, and they're flat. He tells a lie, that one isn't very flat, so just to flatten it out, heat up the solder a little bit, that allows it to sit, and unfortunately the resistors do heat up very quickly and burn your fingers in the process. And there you go, never mind. Okay, so let's finish off soldering the other pins. 1, 2, and 3. Okay, so next thing to do, if I can find my snaps, here they are, my rattling snips rather, and just cut off the legs of the resistors, all very straightforward, like that. Okay, and we'll find a suitable bin to put those in. So, and we have another resistor to put in on that board, and this is a board A, and we need to populate another resistor in R2. So, same principle again. Don't need much solder for these little kits. I'm using very thin solder here. I don't know what the actual size of it is, but you don't need much solder at all. And just make sure that the components are nicely flat against the board. Pop that down there. Oh. And there we go. Obviously a resistor, well certainly these types of resistors are not polarised, so it doesn't matter which way they go round. And that's that resistor in. Good. And now we need to go to the other resistors, which are 4.7k, I believe. I'm just going to double check, make sure. So I'm just popping in the using a multimeter here. See what I'm doing. Just and yeah, 4.7. So the 4.7k. Again, we're on board A, and I've got 3 of those to populate. So take off 3 of these. And they go into locations R1, spread those out a bit, R5. Incidentally, the instructions for this kit is via a downloadable PDF, so quite often if you buy these kits from Banggood, the instructions are a link in the description of the product, so worth noting that. R5 and R3. So far so good. Let's pop these in. So that's blob. solder on that one, but it's good enough. 2, 3. I've got a fairly, what I think is reasonably hot soldering iron, so I am always fairly cautious. It's not, you can't actually vary the wattage on these or the power, so it's 18 watts at 240 volts, which I guess is what I'm getting at the moment. Whether that's high, low, or whatever, I don't know for a soldering iron, but it seemed pretty damn hot to me. So I was pretty cautious about not holding it against components for too long. Okay. There's quite a few LEDs to solder onto this kit, so I'm probably not going to go through all of those with you, but we'll do some of these more major components. Okay, we're still on board A, and the next thing to do is looks like a bunch of resistors, which are 9014. I'll just say resistors, I mean transistors. 9014, I need 3 of these, so there's quite a few here actually. I expect they're all the same value, 9014, so we've got 3 of those, and they go into locations where you can hear Q3, Q2, and that's Q1, and you have to lie them flat on the board. So I'm going to solder those in and I'll get back to you. Just thought I'd show you one of the transistors that has been installed, and if you're not sure which way to go round, the transistors, you can see they have a flat, where am I? Where's that damn camera? There you go. You can see that they have a flat edge on them. And what you need to do is quite simply match it up with the printed circuit board diagram. So we are going to use Q1 for example, and you can see the flat edge there. So when we get our transistor, we will make sure that the flat edge is against the flat edge on the printed circuit board, like that. And in this case, what I'm going to do is I'm going to push it down, and then I'm going to bend it flat onto the board because it needs to be out the way, like that. And then what I'm going to do is I'm just going to solder one of the pins, not all 3, just one for now. I'll do it around this way. Like that. And then what I can do is just pressing on the component, melt that pin again, and it just pops down to the surface of the PCB, so it's a nice flush fit. And then all I need to do is solder the other 2 pins and crop them off afterwards. Don't need much solder for these at all, like that, just a very small amount of solder. So let's crop those pins off. And the final transistor at this stage, there are others to install, goes in there, again flat to flat, and we're going to bend this to the right like that, and again just solder one pin for now, just press the component down with a finger on and melt it, and again it's nice and flat against the PCB, just makes for a nice finish. And solder the other 2 pins, 1, 2, like that. Again, not much solder, and crop them off. And our board is now starting to be adequately populated. Now the next thing to do on this board is to install some electrolytic capacitors. These guys, they are only 47 microfarads. Let's just have a look. Yep, 47 microfarad at 16 volts. And I need, how many of those I need? I need 3 of those. Yep, there's another one. And there's another one. Now, electrolytic capacitors have a positive and a minus. And you can see on there is a minus sign against a short leg. So you've got a long leg and a short leg. The long leg is positive, the short leg is negative. And that's also true for LEDs. So there's an LED, and you see it's got a long leg and a short leg. The long leg is positive, the short is negative. However, what we need to do is, if we look at the PCB, we have got 3 places where we are going to put our electrolytic capacitors, and as you can see, that's a pointer. It's got a plus symbol on one side of each of the silkscreen print areas for these caps. So obviously, because the plus is there, that means the long leg goes next to the plus, and the short negative leg on the other side. So it's like that. And again, rather like the transistors, what we need to do to bend them flat, because that's all part of the construction of the kit. If they're standing upright, I expect the kit won't go together properly. So there's one. Splay the legs out a bit. And again, as always, just solder 1 pin to start off with, like that. And then putting a bit of pressure with your finger on the component, heat up that pin again, and it will go sit nice and flat against the PCB. Solder the other joint. And crop it off. 1, 2. So what I'm going to do now is I'll solder the other 2 capacitors in and get back to you. Okay, so that's the capacitors all in. Perhaps straighten them up a bit to make them look a little neater, like that. And the next thing to do is we have to install on this particular board all the LEDs, and they fit in these locations here, all along here. Now the LEDs, again, rather like the capacitors, have a positive and negative. The positive is the long pin and the negative is the short. And if you have a look at the silk screen, although it's not printed very well, you can see, you may not be able to see, but there is, see if I can, there's the focus, but you probably can't see that, so you can get the light a bit better on it. But one side of the print, so if we look at this one here, that is actually a little plus symbol. So all of the top pins from each of these LED locations are positive. So what we need to do, again using the positive lead in the plus sign, is pop in the LED like that, and then because this is a Christmas tree, we need the LED to come out the side a little bit like that. It probably wants to go in a bit further actually. It doesn't want to, so I'm just going to leave it like that. I think that's good enough. Or is it? No, I'm not happy with that. Let me straighten those pins out again and have another go. I think the problem is that there's kink positions on the legs and they're struggling to get through the holes on the PCB, so the peak holes are quite tight actually. Let's see if I can, you know, they're not going to go through. That's interesting. They are not going to go through any further than that. Because, again, because of those pin location, those flattened areas on the pins. You can see the two dark spots on the pins. They're flattened, which I'm guessing is to help them bend for different applications. I don't know, that may be wrong. But whatever it is, it's stopping them going through all the way. So what I'm going to do is just do it like that. But at least you can be reasonably sure all of the LEDs will be the same. Okay, so we will have to live with that. And as before, what I'm going to do is solder one leg like that, and then I can adjust. That one doesn't need adjusting, that's about right. So that's gone in there neatly. Solder the other pin. Crop it off. And it should end up looking something like that. Okay, so we've got to do LEDs all the way around. Again on this side of the board, again the plus is at the top, so that's fine. So what I'll do is I'll go and install all the LEDs and I'll get back to you. Okay, so we've now finished board A and all the LEDs are lined up. Now the problem I had with this is that the holes for the LEDs are quite small and the legs of the LEDs are quite wide, and this is, and you can see there that the legs are somewhat forced down a bit, and they're sticking out a bit more than perhaps they should do. They should be close to the board, but unfortunately that's the closest I could get there. What I probably could have done is just cut the legs really short, then bend them down, and on a reflection that's probably what I should have done, but there we go. It's going to stay that way now, and of course what I've got to do now is pretty much the same to board B, which is there, so I need to do that. So that will be the next job, so it will just be identical to this one. So what we got, 3 capacitors, about 6 resistors, 3 transistors and a whole bunch of LEDs. So I'm going to populate this one now and see how we get on. Right, well that's both of the main boards, A and B, populated, as you can see, and they're pretty much the same. You'll see on board A that's got a resistor 7, but you don't have that on board B for whatever reason. But there you go. So that's the 2 boards completed. The next thing to do is to populate the base. And as you can see, what we've got here is locations for the power jack and also the switch. So there's the switch, got a nice positive action on that, so that just pops in there. And we then have the mini USB port, which they tend to use a lot on these kits, mini USB, which is no bad thing because they are considerably more robust than, say, micro USB, for example. So that will go on there. So I'm going to solder those 2 up. First of all, put in the micro USB, the mini USB jack, and the switch. So I won't bore you with putting that on. That one's struggling to get in there, so I need to adjust that a bit. So I'll solder those 2 on and get back to you. Okay, so that's the switch and the mini USB jack applied. That's fine. I had to say that the mini USB jack was quite difficult to get in because the holes that are drilled for it are pretty tiny, and it took some force to get them in there. Also, the pins do not protrude above the surface of the rear plate of the board, which means that you have to get your solder inside the hole and don't put too much of it in there because those connections are so close together. You'll easily bridge them. So tiny amounts of solder there. The switch went in nice and snugly, quite tight, but it went in no problems at all. So that's the base plate. The next thing to do is to combine the 2 trees.
Here's something I found on Wikipedia.
Oh, sorry about that. I've got one of those Alexa, Kindle, Amazon Echo Dot thingies, which just started talking for whatever bizarre reason. Anyway, so here we go. These are the 2 parts, 2 plates or circuit boards combined together. They slot together like that, and then they need to be orientated correctly on the board like this. So you've got a plus symbol on the board there, you've got a plus symbol on that board, and basically you then have to place the 4 connections into the board, something like that. And again, just looking at the bottom of the board, you're going to actually be soldering it from the top. You won't be soldering it from the bottom. So you can see that there is a connection on the bottom of the PCB. Are my fingers in the way? Probably. Let's see if I can get this on the camera properly for you. And also a plate on the PCB itself, so you've got to do a bridge solder across those 2. So once you've got one in, the other should be fairly straightforward. So that's going to be a bit fiddly to do that because this thing is wobbling about all over the place like that. So let's have a go at trying to solder those into position, causing too much problem, and we'll see how that goes. So let's solder that up. I noticed that that's a bit wobbly. The other thing I've seen is that there's some connections just here. Now they're not part of the circuit board, but I suspect the idea is that you can put a piece of wire through there, stiff wire or something, and then solder it to make a better connection. But I think once they're soldered onto the bottom of the PCB, that isn't really going to be an issue, but we'll see. Okay, so that's it soldered to the PCB. So you're going to have to do 1, 2, 3, 4, 5, 6, 7, 8 connections at the base, and of course that makes it nice and sturdy. Of course it does wobble at the top there, but no biggie, that doesn't matter. There's not going to be any pressure on it. The last thing to do is to put an LED on the very top of the tree. There, and again you've got your plus and your minus, so I'm going to take an LED. Short pin will go in that side on the right, and the the long pin goes on the right, that's the positive, and the short pin on the left, which is negative. So I'm going to pop that in now, if I can get it in there, like that. And I'm guessing that the best thing to do is just to bend the LED up and try and make it as central across the top of the tree as possible. Something like that. Let's try and bend it in a bit more. So I think what I'll do is I'll just quickly solder that in, and then we can manipulate it a little bit afterwards to get it as straight on top of the tree as possible. Let's just quickly do that now. A blobber there, and a blob there. Okay. Trim those pins off. Like that. And let's straighten that out a bit. That's not too bad. That'll do. And there we have our pretty much completed Christmas tree. So the next thing to do is to see if it works. So what I'm going to use is just this power bank. It's got enough power in this at the moment, so it doesn't need charging. Use the cable that came with the kit. Plug that into the power bank. Plug to the end into the Christmas tree, like that. And let's see if it works. And there she is. One Christmas tree. Let's switch the lights up a little bit so you can see the tree. Now I see I have got an LED there that doesn't look very happy. So that one I think needs replacing, and so does that one. Let's have a look around here. Now we've got a few LEDs that aren't looking too happy here. Most of them are okay. These are all okay. But some of these are not so clever. So, need to replace a few. Okay, right, I replaced all those LEDs, but unfortunately I am a blithering idiot, because the reason those LEDs weren't functioning correctly was because I managed to get two resistors swapped in the wrong places on board B. I've swapped those resistors round after having unnecessarily replaced about 6 LEDs. And also installing 2 LEDs that I forgot to install or missed installing in the first place. So all in all, not great. All my fault, nothing wrong with the kit. But there it is. That's basically the completed kit. All I'm just doing here is just bending the LEDs down so that they're all uniform, so that they give a decent display when they go off. There's actually quite a lot of LEDs on this particular kit. Haven't counted them all, but the great thing is about these kits from Banggood is that they always provide you with a lot of spares. Sorry, I was off camera there. They always supply you with a lot of spare parts, and if I sort of, okay, well, some of this is hardware that we need to use to build the case, which we'll do in a moment. But you can see I've got 3 transistors left, an electrolytic capacitor, I've got a resistor hanging around there, and I've got a bunch of LEDs as well. So, you know, they always tend to give you extras in case of errors, and in case these kits are purchased by idiots such as me. So anyway, there we go. So I've now replaced the resistors in the right place, as I said. So let's have a look at how she operates. So power on, and there we go. Shall we try? Let's try reducing some of the lighting, and everything is now flickering. The LEDs are changing colour as they should. The very top LED is constantly lit, which kind of makes sense. Top of the Christmas tree, as it were. And yeah, that's looking quite nice. So the next thing to do is to start constructing the case. So let's switch this off and unplug it, get a bit more light on the scene. There we go. So yeah, the case is one of these transparent, obviously, acrylic cases, and I kind of like them. The cases are always quite thick in manufacture. They're well protected during transport because they have this paper backing all over them, which is great because you don't get any scratches during transport. The only downside is that you've got to peel all this damn paper off. So I'm going to do that now. I don't think you need to watch me peel paper off, but in case you've never seen these things before, let's just start this one off. And as you can see, it comes off reasonably easily. If you do it slowly, I mean, obviously the trouble is with these kits, the actual shape of them doesn't really lend themselves too easily to being peeled off in one go in all cases. But there you can see the plastic case underneath. So these can be a bit fiddly to peel off. And of course the important thing is that when you're putting the case together, is to make sure that the part of the case that goes on the inside isn't covered with fingerprints. Otherwise you'll end up putting all the case together and realise it looks a disgusting mess, and you have to take it all apart again, clean it, and then start again, which is no fun. So just be mindful of that when you do it. So there we go. You can see it really is a nice clean case. Fingerprint magnet, so you need to be cautious of that. So I'm going to take all of these, all the covering off, the paper covering, and we'll have a look at the construction of the case. Okay, so all the paper is now off the respective pieces, as you can see here. Sadly, one of them was delivered with a really nasty scratch on it, which you might be able to see there. But yeah, there you go. These kits are very, very cheap. I suppose investment in quality control is not always going to be on top of their list of things. But there we go. As you can see, there's 4 of these side plates like that, and these bits at the end, they're the feet which the device will stand on. We've got some brass nuts here which screw into the base, and then the plastic base will screw onto that. I'm not going to go through the whole process here because there are instructions that come with the kit, and it's fairly straightforward. Everything's held together with nuts and bolts, or screws and bolts in this case, and it actually makes a very strong case. So what I'm going to do is I'm going to now put the whole thing together, and once it's complete I'll show you. Okay, so that's the case installed. These are all the parts that are left over, spare parts if you like. Quite a few there: transistors, capacitor, resistor, nuts and bolts, bits and pieces. Keep those for... So the case assembly was fairly straightforward. It's all held together with this nut and bolt system. Very robust once it's all together. No problems at all. Stands nice and level, and good idea to have it in a case. Keeps little fingers away from it. Of course this is only 5 volt, probably a few hundred milliamps at the most current being drawn on that, so it's not dangerous, but obviously the components are quite sharp, so it's a good idea to have it in a case like that. So let's just plug her in and power her on. Bring the lights down a little bit, and there she is, the completed Christmas tree from Geekcreit on Banggood. And it was, I think this was about £10 UK, and you know, for what you're getting, it's not a lot of money. It works, and yeah, it's very effective, looks nice. Happy with that. Anyway, I hope you enjoyed the video. It was a bit bitty, and I did do it over a couple of nights, so it's not the greatest video I've ever made. Not that any of my videos are necessarily great, but there you go. But I hope you enjoyed it, and I certainly enjoyed making it. And I've got quite a few kits from Banggood. I kind of addicted to them. I do like building them. It's nice to spend an evening constructing something, and you've got something at the end of the evening to show for it. Any road up, there we go. That's that Christmas tree, and it's the 2nd of December, so 2017. Merry Christmas to you all. Cheers.